No one announced it with flashing headlines. No emergency broadcast. No official press conference declaring anything alive. But buried inside raw telescope data, something changed. James Webb was doing what it always does, scanning the cold, silent dark between stars, when astronomers noticed an object that didn't behave like it should. Not violently, not dramatically, just wrong. Quietly wrong. Subtly wrong in a way that made scientists pause longer than usual before hitting publish. The object was labeled 3I, Atlas. Only the third confirmed interstellar visitor ever recorded entering our solar system. That alone should have made it historic. But history wasn't what unsettled researchers. It was the behavior. Interstellar objects are supposed to be dead, ancient, frozen leftovers from star systems long gone. They drift for millions, sometimes billions of years, without change, no energy, no reactions, no internal activity, just cosmic debris passing through. 3I, Atlas, didn't follow that script. From the very first observations, its trajectory raised questions. It wasn't just moving fast, it was adjusting. Subtle changes in velocity appeared where none were expected. Not enough to scream propulsion, but enough to make gravity-only explanations feel incomplete. That was the first red flag, and it was easy to dismiss. Space is messy. Models aren't perfect. Then James Webb took a closer look. Infrared readings revealed faint heat signatures, unevenly distributed across the object's surface. That was odd. Heat in space usually comes from sunlight or radioactive decay, both of which follow predictable patterns. This didn't. The warmth appeared to fluctuate, not randomly, but rhythmically, as if something inside the object was responding to its environment. Still, no one panicked. Yet, the next discovery was harder to wave away. Spectral analysis detected complex organic molecules, carbon-based structures arranged in ways that usually require ongoing chemical processes. Not proof of biology, not even close. But also not something expected inside an inert interstellar rock. Scientists began using cautious language, very cautious. Instead of comet activity, they used phrases like internal chemistry. Instead of outgassing, they described non-uniform emissions. These weren't dramatic words, but they were deliberate. Every term chosen avoided one idea without denying it: life. What made this unsettling wasn't just what was detected, but what wasn't said. In science, silence often speaks louder than speculation. When researchers avoid ruling something out entirely, it means the data doesn't let them. And then there was the timing. As 3I, Atlas, moved closer to the inner solar system, its signals changed, emissions intensified, infrared patterns sharpened, Webb's resolution improved with proximity, and the clearer the image became, the less comfortable the explanations felt. This wasn't a single burst of activity. It wasn't a one-time reaction. It was sustained. Somewhere inside that object, something was happening, and it was continuing. At this point, comparisons to Oumuamua resurfaced. Years earlier, that interstellar visitor baffled scientists with its acceleration and shape. Some suggested exotic hydrogen ice. Others proposed nitrogen shards. A few whispered more controversial ideas and were quickly sidelined. 3I. Atlas reopened those conversations. But this time, the data was better. James Webb wasn't guessing. It was observing with precision humanity has never had before. And what it saw didn't fit neatly into known categories. Not asteroid, not comet, not debris behaving passively. There were delays in publication. Peer reviews took longer than usual. Internal discussions stretched out. None of this was public at first, but patterns emerged. Astronomers don't stall unless something forces them to double-check everything. And then came the phrase that quietly changed everything: active internal processes. That line appeared in a draft summary and was quickly revised. The final version softened it, but the meaning remained. Something inside 3I, Atlas, was not dormant. Still, no one claimed intelligence. No one claimed organisms. But here's the part that unsettled even seasoned researchers. The activity appeared responsive. As the object encountered increasing solar radiation, its emissions didn't simply increase. They shifted. Different compounds appeared at different distances. almost as if internal reactions were adapting to new conditions. Adaptation doesn't equal life, but it also doesn't equal dead matter. At this stage, monitoring intensified. James Webb wasn't alone anymore. Other observatories were brought in quietly. Data streams multiplied. Every change was logged, compared, debated. And all the while, 3I, Atlas, kept coming. Its path brings it closer than any interstellar object previously observed with this level of instrumentation. Each day of approach improves resolution. Each improvement removes excuses. This is where the conversation subtly changes. For decades, humanity has searched for life by looking outward planets, atmospheres, distant stars. But 3I, Atlas, suggests a different possibility. What if life, or something close to it, doesn't need a planet at all? What if chemistry can persist, evolve, or maintain complexity inside interstellar objects, surviving the void itself? That idea alone would rewrite biology. Some researchers now propose that what James Webb is seeing isn't life as we know it, but pre-biological systems, chemical networks capable of self-sustaining reactions. Systems that aren't alive, but also aren't inert. A category science doesn't currently have a name for. And that's the problem. When you don't have a name for something, it means you don't fully understand it. Publicly, agencies remain calm. No alerts, no warnings, no claims. But behind the scenes, protocols are being reviewed, not because of danger, but because of significance. If 3I, Atlas, represents a new class of interstellar matter, everything from planetary formation theories to the origin of life must be re-examined. And then there's the human factor. If this object carries complex chemistry across star systems, it means the building blocks of life are far more mobile than we thought. Life, or near life, may not start on planets and spread outward. It may drift through space, waiting for the right conditions to ignite. That realization alone changes how rare we are. As 3I, Atlas continues its approach, James Webb will keep watching. Every emission, every fluctuation, every anomaly, scientists will continue choosing their words carefully, not because they're hiding something, but because they don't yet know what they're looking at. And that uncertainty is the most honest answer science can give. Nothing has been confirmed. Nothing has been ruled out. But for the first time, an object from another star system isn't just passing through silently. It's reacting, changing, doing something. And the closer it gets, the harder it becomes to ignore the question no one is ready to answer yet. What if alive doesn't mean what we thought it did?